For number 4, I'm going to get you set up with this problem, but I'd like you to try to come with the solution on your own to class, and we'll discuss then. So we've got T1 here, we've got T2 over here, and we have FG pointing down. You see how I drew the free body diagram there. Now what we're going to do is we're going to split T1 and T2 into their respective components. So we'll have T2x pointing this way, and we can also, I think I might just move this here. Let me just really quickly draw T2y right here, and let me just go back and relabel. This will be T2. And then here for T1, let me also just carefully label that again. Here's T1. And we're going to label its components as here T1x and T1y using vector components. Now, to be clear, if you remember when we deal with vectors, if this is a vector v, so if this is a vector v, and this is the angle theta it points at, then we have x and y components written like this: Vx, V cos theta, Vy, V sine theta. The problem here is that we don't actually have any values for these tensions, and we're going to actually have to set up the physics and use algebra to solve. So here, vertically, I'm going to have T1y plus T2y minus Fg equals 0. And just a reminder, the gravity force, or the weight, is 200 newtons because it's 20 times 10. So ultimately we're going to have T1 sine of 70 plus T2 sine of 30 minus 200 equals 0. And your second equation is going to be T1x minus T2x equals 0. Whoops. Let me just clean that up a little bit. There we go. Now finally, putting in our trig values, that's going to be T1 times the cosine of 70 minus T2 times the cosine of 30 equals 0. So these are the two equations you need to solve. Now, what I'll do is I'll actually write out a solution for you in PDF form, but I'd like you to try to actually solve this based on the work that we've done in class. So this is the homework that's due. Now this one here, this is a challenge problem based on Newton's third law. And for those of you that are interested in this extra challenge, I just want to draw a free body diagram to get you started. So you'll have a normal force. You'll have the weight of little m. You'll have the normal force on big M and the weight of big M. Now here's the deal. We've got F pushing on little m. It hits big M, and so we have a force on big M because little m pushes it. That's the action force. The reaction force is that we have a force on little m due to big M, and because of Newton's third law, these two forces balance. We can also write our balanced forces here, here, and here. So that's the free body diagram for the challenge problem. For those of you that are interested, I want to challenge you to try to actually set this up and solve based on these numbers.